Okay. All right. So welcome to our second lecture in Unix. Let me change this view to present. And we were looking at some of these commands, diff, kill. I don't know if we did these last time. Uptime, uname, mount, df. Did we do these?
I think we did DF.
We did the df. Then we must have done diff. Diff shows the difference between.
I remember doing kill.
Yeah,
We did kill. I don't think we did any of the others.
All right. So let me review them anyway. That was my plan. New share. So if I have, for example, a file called foo, and it has hello 1, hello 1, hello 2, hello 3. And if I have another file called f2, hello 1, hello 1, hello 2, hello 4, the last line is different. So watch what I can do. I can do diff f2 foo. So what it shows me is that the left file, which is f2, has hello 4 on the fourth line, and at that's and at that same place, hello foo. Foo has hello 3. So the arrows tell me that the right one has hello 3 and the left one has hello 4. So diff shows me the difference between two files. Kill, we said, sends a signal. Time, I can do like this. Time diff f2 foo. And what this does is not only what this does. Oh, I typed foo wrong, maybe. Yeah. What it does is it runs foo. It runs a diff f2 foo and shows me the difference, but it also times the action. And it shows me that it took 2 seconds in real time. Or actually not 2 seconds, 0.002 seconds. Very little time. It also shows me that the system time, the CPU was 0 seconds, but in user mode, I use the CPU in user mode in that same amount of time, 0.002 seconds, but I use it in the root mode, in super user mode, 0. I didn't use super user at all. So it times my process, whatever action I want to do, I can time it. There's also a command called last, which shows me shows the listing of the last logged in users and when they logged in. But all right, not important.
There's people in the waiting room. Can you let them in?
I let one person in, yeah. Uptime. If there's another one, I don't have any more, I don't think. If I do uptime, people like to brag about their uptime. How long has my system been up? It's been up since 5:13. Just opened it. 8 minutes. I don't know. The timer seems to be wrong. Oh no, that's the current time. It's been up 8 minutes. That's the current time, and it's been up 8 minutes. So, right. It also tells me the load average, how much I've been using my CPU. That's uptime. Then there's uname. It tells me that I'm running a Linux machine. And then there's uname minus A, which tells me more information, which exact kernel I'm running, which means which version of Linux I'm running, the kernel is the essence of the operating system. So which version of the kernel. I also have mount minus L, and that shows me all the mount points, which means all the disks and where they're mounted, where every disk is and where it's mounted to on the system. Mounted means like connected. The disk, you see, there's a concept called mounting, which means you have to connect a hard drive to a particular place in the file structure. You see, in Windows, it's pretty simple. It just, every time you put a new disk in, it gets a new letter. But then each letter, there's no hierarchy between them. What and in Unix, I can actually have a hierarchy. So I can say I can actually mount a disk in some subdirectory that I choose. Okay. And there's df. So mount minus L lists me, L's list all the mounted file systems. Df shows me the disk free, what disks are, how much of them are used. 80% of this one is used, 0% of these disks are used. And this disk is mounted on, now there's a disk, well, it's called none, but whatever. There's a disk here, SDB is mounted at /. And notice this, here's what's interesting. C and D, which are my two Windows directories, that's what's interesting, are mounted. Those are my two Windows files. My computer, my laptop actually has two separate hard drives. The D is bigger. Now, the D is mounted at a mount point called MNT mount D. And this is mounted at a mount point. So in my file structure, I can actually go to my Windows Windows files and see them all there in mount C or mount D. So it shows me the mount points in disk free. Did I see it in mount? I should have seen it also somehow in mount minus L. Yeah, here, C is on mount C, and it tells me more information. What type of mounting it is. We'll learn about some of this towards the end of the course, what this means. But essentially, for right now, it just shows me that C is mounted at this place. These other stuff are like maybe virtual disks, not real stuff. It's not really important. Okay, that's the basic idea of mount L and df. So you see, I have a lot of system commands that I can see stuff. These are just functions that, as time went on, Thompson or people who wrote Unix added functions that they thought would be useful. They just wrote stuff, and you can keep adding stuff yourself. Okay, that's the end of lecture 1. I don't know if I'll go to lecture 2. For some reason, I thought we would have already been in lecture 2, but lecture 2. Let me change the share. And here we are, Unix system lecture 2. And pipelining. So this is we talked about this, but not right. We did examples of this, but I'm just showing it to you now in a more organized way. Use the pipe symbol to pipeline or chain together modular commands. Essentially, the pipe sends the output of the first command to the input of the second command. So you have commands. So for example, I might do cat a file, and then the output of that cat, which would normally go to the screen, will instead go to the function sort, which will sort it. Then I will send it to the function unique, which will give me only lines which one after the other do not repeat. Unique lines. And as it won't print, it will remove duplicate lines. And then I'll count with word count how many lines I got, how many characters I got. So I can have the output of one command go to the next. We call these filters because essentially the output of this is being filtered through a sort command. I'm not actually changing the file. File.txt is remaining what it is, but I'm sort of pouring it through a filter that sorts it, then through another filter that finds the unique lines, and then another filter that just finds the word count. How many lines and how many words, how many letters. Okay. Now we're back to a simple example. We did something like this, I think, you've seen this, echo hello, prints hello. Now we're starting in our most basic or simple sort of programming language. This is called, these are utilities. These are like utilities, which are also like languages kind of. But this is a very simple one. TR is short for translate. Translates and deletes characters from a standard input and writes the standard output. And the syntax is TRs, flags, and two sets of letters. where set 1 and set 2 are, where set 1 are translated to set 2. So for example, if I have echo, quick brown fox jumped over the lazy dog, and I translate ABC to 1, 2, 3, it's going to find the ABCs in this and change them to 1s and 2s and 3s. So the quick has a C in it, so it'll be a 3. It'll match the order. A is 1, B is 2, and C is 3. Brown becomes 2, and lazy, the A over here, becomes 1. What about if I translate all these letters to 1, 2, 3? What's going to happen? I don't have the same number here and here. So what happens is the 3 sort of clobbers them all. It grabs everything that's left. So only the 1, the A and the lazy, and the 2 and brown, but the C and quick, and the F, and the E and the D, all of them become 3. So that's now, why is this useful? This is useful because in DOS, sometimes the ending character or the end of a file or end of a line in DOS is sometimes 2 characters or a different character from what it is in UNIX. So if you want to, sometimes you'll see garbage at the end of each line of your file in Linux when you look at it in Unix. So you want to translate the file. You want to translate those funny end lines to regular end lines with the tr command. That would be one use. Anytime you have data that you want to manipulate, you can use this tr. Here's some more examples. Echo, the quick brown fox jumped over the lazy dog. Pipe it in to translate all the A's, all the lowercase to all the uppercase. I can do a range. So now it becomes now it becomes what the echo is. I mean, the echo is going to be piped into tr, and tr is going to print quick brown fox jumped over the lazy dog in all caps.
How do we
The
know
same
when
example,
a command-
I can get the same result by using a keyword lower and upper. I put colons in front and after. Question?
Yeah, how would we know specifically when a code is only looking at when we're using pipeline will only affect the first occurrence of something opposed to iterating over everything?
Well,
Like with-
tr iterates over everything. That's
yeah, I'm
just-
saying. Does it
How would you know? From experience or from reading the manual.
does it say in help, whatever command help, will it say it right there in the manual, or
Yeah,
or is
if you
that
read the manual carefully, you just do man tr, and it'll say, it won't tell you specifically, but it won't say otherwise. It'll just say, translate the letters in the thing. It doesn't say translate the first occurrence. So here we do quick brown fox, and I translate. Now the space, I have to translate the space. I need to put it in quotes because otherwise it won't think there's anything there. Translate the space to a new line. And then I get quick brown fox. I can also do echo quick brown. I can delete a letter. So translate minus D is delete. Delete anything which is a digit. So it becomes quick brown. You see, this can be useful. And quick brown, I can also replace a digit with the letter A if I want it for some reason. Okay, next command, cut. Yeah, we're gonna have one page on cut. Cut is also a simple command. I'm starting with some simple ones. We'll get to more complicated ones. Cut says like this. Field. Now what we're gonna do is we're gonna cut and only print certain fields of a line. Fields of a line means that the line itself logically is divided into fields. Well, that means there has to be something that divides it into fields. We call that a field separator. We also call it a field delimitator. So the field separator needs to be specified. So let's see what this first example. Display the first field of each line using tab as the field separator. So if I don't specify a field separator, the default is a tab, which is sort of unfortunate because I would prefer it to be a space, but or something else. But the tab is not. You know, we in Excel, you can export your file to a comma separated value file. So then you would have a comma as your field separator. So if this will display the first field of the first, everything up to the first tab in each line of the file. This works on each line. I can also give it an echo, in which case it just gets one line. Now there I give it a file. Here I'm going to give it an input. You see, I'm using the pipelining, and it's going to read from the standard input instead of reading from a file, which would be at the right side here. So I'm going to send it A:B. I did this because I want to show you the contents that I'm working on, so you'll understand the output. So I cut, and my delimiter, the -D, is the delimiter. Or you see, I call it field separator, but I guess it's a delimiter. In some languages, they call it separator here. So here it's -D is the delimiter, colon. So I'm using a colon as my delimiter, and do the second field, -F2, field 2. Here was -F1. So I'm going to print B. If I wouldn't have defined the field delimiter, it would have printed the whole line because it would never have reached a tab. Now I'm going to do echo ABC, and I'm going to say that my field delimiter is a space, and I'm going to print fields 1 and 3. So it'll print A and C. Here I'm going to print fields 1 to 3 and also 5, the range. So I'm going to print A, B, C, E. Here I'm going to print 2, 3, 1, but it's actually going to output ABC. I wanted to print it in reverse order, but it won't work. It just telling the order here does not matter. I'm just telling it which fields I want. It's going to print them in the order that it hits them, not in the order that I write them here. So it will disregard the reversed order. Echo fields from 2 until infinity. So that means everything after 2, it'll output B, C, and D. Echo A, B, C, D, cut 3, 4. So if I give it something that I don't give it, sorry, so now I'm giving it a C. See, F was a field. Now I'm giving it something more complicated, C, character. Characters 3 and 4. So I'm going to get C and D. And here I'm going to do fields. I'm going to do characters 1 to 3 and 6 to 8. So you see, I can use the -F and the -C. Now, of course, you can see all of this if you type man cut. Or if you look on Google, UNIX cut. You just type UNIX cut, you'll see all about it. Okay, now let's talk about variables. Define your variables with this equal sign, and it's important. This is Bash already. These are variables in Bash. I should have written that here, but maybe I will. So you define your variables in Bash by writing the variable name, followed by an equals, followed by whatever you want to define it as, a string, hello. So notice there's no type. I don't say that it's an int or anything. It's just a variable. Also important is that there's no spaces here. Then I could actually type, I could say A = 1, and then it would be like a number. But now it's a string. But when I use the variable A, I must precede it with a $sign. So I want to print $A. If I want to print A and get hello, I got to put $A. Now, another thing is, wait a second. Use variables beginning with a dollar sign. Okay, without the dollar, you would just do echo A, you just get an A. So I wanted to say that in C++, you can also have a variable name starts with a dollar. You can't have a variable name that starts with, let's say, a percent sign or I don't know, a pound sign. But a dollar you could, because of inheritance, because of there's languages that use dollar variable as their variables. So C++, they let people write that also. But here you must write a dollar. I can also redefine a variable. For example, A equals AA. So now when I do echo A is no longer hello, it's AA, hello, hello. Now, a lot of people make a mistake here and they put a dollar in front of this A because they think, oh, I defined it and now I'm using it over here. But essentially, you're not using it, you're redefining it. So you again do not write a dollar here because I'm defining it now. But I do write a dollar here because I'm using the value that it already had. If I use what if I would write $B over here? $B. So A would be defined as the empty string. In other words, it would be defined as nothing, but it wouldn't give me an error. There's no such thing as an error. If I did echo Q over here, it would be fine. It just would print nothing. Okay. Now we get into a complicated topic, which I'll talk about a few times. Single quotes won't interpolate anything. There's single and double quotes, but double quotes will interpolate. Interpolate means interpret. So, for example, if I do echo quotations, I'll still get hello, hello. No change. But if I do echo with a single quote, it's going to print me the literal string $A. In other words, it's not going to interpret what $A means. It's going to print me the string $A. So that's useful if I want to print something like that. This is a bit of a complicated example, but I'm going to skip this one. We'll talk about it later. But here, what am I doing here? I want to print this complicated thing here exactly as is. So I put it in single quotes and it prints it exactly as is. This particular one, it's something else. It's not, this dollar means something else here. And it's just running. I'm running this command. Doesn't matter. The point is here, I got something else. It did something. It interpreted it. Here, it didn't interpret it. It just printed it as is. This is, I'm not going to read this to you now because my voice is not so good, but after teaching all day, but this is a definition that I copied from the manual of Bash. There's a manual of Bash, which is very long.
Under man.
There's a manual of the man. Yes, there is man. Great question. You can do man. But there's no man woman. But there's a male man and there's a male woman. Yes, it'd be a funny job if you're a woman to be a male woman. Sorry, those are my jokes. Okay, manual page, file access modes. Now we're on to another topic, which is important. And usually I have one question like this on the exam. A file can be read from R, written to W, and executed if it's an and those are called file access modes, or sometimes called file permissions. But technically, it's modes. These characteristics of a file can be turned on or off by the file owner or by the super user. There are 3 sets of users who may be granted these rights. So, for example, this file has read, write, and execute for the owner of the file, read, write, and execute for the group that the file owner is in, and read, write, and execute permissions for everybody else in the world.
Professor, I think Ellie's in the waiting room.
Really? I just let in some people.
Came a little late.
I can check. I don't see anybody in the waiting room. I generally get a little note that says when somebody's waiting, and then I let them in. Okay, so let me go straight to an example because this is hard to understand without an example. So stop share and make a new share. Nobody's in the waiting room. New share, share screen. And there we are. And share. And I can go like this. Wait, yeah, wow. H1 says echo hello. What are the rights of this file? What are the modes? ls minus l h1. I see that it has modes read, write, and execute for the owner of the file. I can remove those by doing the following: change mode, ch mode, and then I can do all, or actually user minus a. I think that's correct. Let's see. No, sorry. Well, I can do user minus x. And now if I look at it, oh, I want to do just on the one file. And I see that the x went away. I can do user minus r, and the r goes away, and user minus, user minus w, and the w went away. And now if I do like this, and I look at the file, or I do ls on minus l on h1, I see it has no permissions. And if I try to do cat on the file, h1, it won't let me cat. It will tell me permission denied, because I don't have permission to, and nobody has permission to do anything with that file. But, and if I try to execute the file like this, permission denied. But if I go like this, change mode, user, which is me, plus read. Oh, I got to give it a file name, h1. And now I try to do cat. All of a sudden I can cat it again. But if I try to execute the file, h1, permission denied. I don't have execute rights. So I have to give myself execute rights. Change mode, user plus execute, and h1. And now if I try to execute the file, it's going to run and print hello. Notice when I cat the file, it gives me the content of the file, echo hello. When I run the file, it runs it, which echoes hello. So let's look at the permissions again. H1, no, ls space minus l, h1, and I see that it has write and execute permissions for me. If I try to do something like echo hello into the file h1, permission denied. Why is that?
Because you don't have access.
Which access don't I have?
Right.
Right. You're not right. You can read and execute.
Right, I read and execute, but not write. So I can't write.
You change it so easily, then who cares? Like, what's that? Why is that secure?
Well, this is it for me, but I can say like this: if I share, if I put this file H1 in a joint directory, in a directory which is shared by you and me, then you'll be able to read it and execute it, but not change it in any way, not delete it, not write to it, but you'll be able to use it. So if I write a program and I want you to use it, but I don't want you to delete my program, so this is great. Now, wait a second, you can't, only I can. So I'll have to do it like this. I'll have to do change mode, other, plus, I think I forget, read.
Can't you do it with numbers, like with 7 and 1?
Yeah,
number
I'm going to
3
do that. There, look what let's see if that worked. Probably that worked. Yeah, look what I did. I did change mode, other, plus read and execute. H1. So now everybody else can do read and execute. I can even do like this. Change mode, all, everyone, plus RX. Oh, I keep forgetting to write the file, H1. So now everybody in the world can read and execute it, but nobody can write to it. So that's like security. That's very secure. Everybody in the world, as long as this file, is in a directory that they have access to, then they can read it and run it, but they can't change it, which is great. Now I can do like this, change mode, user plus write, H1. And now I can change it, but nobody else can. The owner has everything. Now, you might ask, why would I not want to do that? Well, I might be that I finished working on this file and I don't want to change it even accidentally. So I don't want to accidentally delete it. I don't want to accidentally write something. So I'll remove from myself write permissions. And then if I do actually want to change it, I'll change that. But it gives me a two-step process to change it so I won't accidentally change the file. But it also gives me complete control. I can let other people, I can also let people, I can let people write it or let people not let people write it. But they'll still be able to run it or execute it. Now, we also have directories. If you look at a directory, it has, here's a directory. It has read, write, and execute permissions. What does it mean to read and write and execute a directory? Well, what do you think reading means?
Reading from.
List the files inside.
List the files inside. What does executing a directory mean?
Executing a file inside the directory? No, I never.
Good guess, but no, it's not executing a file inside the directory.
Directory.
What?
Does that have to do with if there's commands inside of the file?
No, not well, sort of, but not, no. What it means is, it's a hard one to guess. It means going to the directory, going inside the directory, CD to the directory. If I want a CD to a directory, I must have executable rights. Executing a directory means executing. What does a directory do? Lets you go into it. So executing a directory means going into the directory. And what does writing to a directory mean?
Adding a file.
Adding or deleting a file. So I could let people read and execute my directories, but not write my directories. I don't want them to delete my files. So that means even if I have a file, so it's complicated now. Even if I have a file inside a directory, which is world, well, it's complicated, is world writable, but the directory is not writable, then the person, what will he be able to do? He'll be able to go into the directory, but he won't be able to write, which means he won't be able to delete or create any files, but he could write to this file. So therefore, what he could do is write nothing to the file, overwrite the file. He might be able to blank out the file, remove everything from the file, but he won't be able to delete the file. So I also want to make sure that the files themselves are not world writable. And so there's an example of how you see that directories are treated like files. They have the same permissions. The permissions mean something slightly different. Now, somebody said there's another way to do it, and the way I did it was a very clumsy way to do it. The normal way to change files is like this. Change permissions is like this. Change mode 700, for example, on H1. Now, 700 means all of these three. If I did 777, then look what it means. All of them get lit up. What's going on? If you think about it, these R and W's are in the first place can only be, in the first place is a D, possibly, if it's a directory, or an L if it's a link, or a line if it's a file. And in the second place, it's RWX. Second, third, and fourth place, RWX. So these 3 bits are actually just bits. In other words, R is essentially 1, W is 1, and X is 1. If it's lit, then the computer knows to write an X there and a W there. But essentially, it's a 1. Well, if this is a 1 and this is a 1 and this is a 1 and it's binary, then it's 7 because this is 1 plus 2 plus 4. That's 7. So 7 indicates the first set. That's this 7. The next 7 is the next set, and the next 7 is the next set. So if I do, for example, 007, now I don't have permission, but the rest of the world does. And I can also do a common permissions that you might do is 755. Why? Because this says, this is a very logical one, because it says, me, I get everything. I get all the permissions. The rest of the world, the group that I'm in and the world get read and execute, but not write. So 5 is because I want to light up the first bit and the third bit. So 4 and 1 is 5. So once you start viewing it as binary numbers, it's actually easier than remembering the letter codes for everything. All right, I want to take a break here for 10 minutes. So let's take a break and I'll come back. No.
Forget to pause the recording.